Good morning, students. Welcome you all for next generation learning. Today we are going to see the subject physics, class 9, chapter 9, force and laws of motion. Under this chapter, there are the 6 topics. 9.1 Balanced and unbalanced forces. 9.2 First law of motion. 9.3 Inertia and mass. 9.4 Second law of motion. 9.5 Third law of motion. 9.6 Conservation of momentum. Today's topics, I am going to give a revision for the full lesson. The first one is, what is a force? Push or pull of an object is called force. The unit of force is Newton. It is represented by the capital letter N. The quantity is vector quantity. That means it has both magnitude and also direction. The next one is effects of force. What is meant by effects of force? A force cannot be seen. Yes, we cannot see the force. A force can be judged only by the effect, which it can produce various bodies around us. So what are that effect? A force can move a stationary body. Yes, if you take, this is a ball and the state of this ball is rest. When I applied a force, is starting to the move. So a force can move a stationary body. In second one, a force can stop a moving body. The example, suppose a cricket ball is moving towards you. How you can stop this cricket ball? Applying a force on the ball, we can stop this moving ball. So force can stop a moving body. The third one, a force can change the speed of a moving body. For applying a force, we can change the speed of the moving body. The fourth one, a force can change the direction of a moving body. So the object is moving in this direction. When we are suddenly apply a force, we can change the direction of the object. The fifth one, a force can change the shape and size of a body. See here, this is a spring. When we apply a force on the two sides, the size of the spring is elongated. So we can change the size of the object by applying force. And see the shape of the balloon. When we apply a force on the balloon, the shape of the balloon is changed. So these are the effect of force. A force can move a stationary body and can stop a moving body. It can change the speed of moving body and it can change the direction of a moving body. It can change the shape and size of a moving body. These are the effects of force. The next one, the balanced and unbalanced forces. What is meant by balanced and unbalanced forces? If two individual forces are equal magnitude and opposite direction, then the forces are said to be balanced. Look at this image. So these three members apply a force. These three members apply a force in this direction. These three members applied a force in this direction. So two individual forces, there are the two individual forces of equal magnitude. See, here also 300 Newton and here also 300 Newton. Newton is the unit of force. So, equal magnitude, but the force direction is opposite direction. This type of forces are called balanced force. When the two forces acting in the opposite direction with equal magnitude, such type of forces are called balanced force. So 300 Newton minus 300 Newton. The minus take in the forces in opposite direction. So we get 0. When two individual forces, when the two individual forces in opposite but different magnitude, here 300 Newton and here 400 Newton. This type of forces are called unbalanced force. Two individual forces in opposite direction with unequal magnitude. Such type of forces are called unbalanced force. Here 400 Newton, this force is opposite to 400 Newton, so minus 300, so we get 100 Newton. This is the difference between the balanced and unbalanced force. In balanced force, the magnitude is same. In unbalanced force, the magnitude is different. The next topic is Newton's first law of motion. What is meant by the Newton's first law of motion? This is a statement of the Newton's first law of motion. A body at rest will remain at rest, and a body in motion will continue in motion in a straight line with a uniform speed, unless it is compelled by an external force to change its state of rest or uniform motion. First, I will explain you. A body at rest will remain at rest unless it is compelled by the external force to change its state of rest. Okay, this is the first one. The second one, a body in motion will continue in motion unless it is compelled by the external force to change its state of uniform motion. Here the external force is nothing but the force from the outside body is called external force. So a body at rest will remain at rest unless it is compelled by an external force. Look at this diagram. Here the book is on the table. The state of this book is rest. So unless applied by the external force, the book does not change their position. So we can say that a body will remain at rest, it continue at rest unless it is compelled by the external force. Look here, the bicycle is moving. So a body in motion will continue in motion unless it is compelled by the external force. But here one condition is very important for moving. If there is no air resistance, you know that we are surrounded by the air. If there is no air and if there is no frictional force between the wheel of the cycle and road, if there is no frictional and if there is no air resistance around us, means the moving body will continue in motion unless it is compelled by the external force. This is called Newton's first law of motion. Do you understand what is meant by the Newton's first law of motion? If body at rest means it will remain at rest. A body in motion means it continue in motion until an external force is applied. If you applied the external force, it can change the state. Because here the book is at rest. But when I apply a force on this book, it can change the state. So until applied the external force, it cannot change the state. The next one is inertia. What is meant by inertia? The tendency of a body to remain at rest, or if moving, to continue moving in a straight line is called inertia. So the same thing, the Newton's first law, what the Newton's first law is given? The body at rest, the body remain at rest, and the moving body continue in moving. The same thing, a tendency of a body to remain at rest, or if moving continue to move in a straight line is called inertia. The inertia is always resist to change the state of motion. Resist to change of the state. Inertia is that a property of your body to which it resists a change of state, rest or uniform motion. If body at rest means it always be like to be rest. If body is moving means it always like to be in moving. This is called inertia. The inertia and Newton's first law is the same concept. So how to measure the inertia? Mass is a measure of the inertia of a body. So by measuring mass, we can know the inertia of a body. If a body has more mass, it has more inertia. If a body has less mass, it has less inertia. Here I took cricket ball and plastic ball. Comparing to the plastic ball, cricket ball has more mass and the plastic ball has less mass. So the cricket ball has more inertia and than the plastic ball. Do you understand how to measure the inertia? By measuring the mass of your body, we can measure the inertia. If more mass means more inertia, less mass means less inertia. For understanding this, here I took cricket ball and plastic ball. Comparing to the plastic ball, cricket ball has more mass. So it has more inertia than plastic ball. The next one, momentum. So in order to understand Newton's second law of motion, we should first know the meaning of the term of momentum of a moving body. You have to know what is meant by the momentum. Here I took one cricket ball and one tennis ball. It has more mass, we know that, and it has less mass. Comparing to the cricket ball, the tennis ball has less mass. I throw these two objects in the same speed. The 5 meter per second for cricket ball and 5 meter per second also tennis ball. So if I stop this cricket ball, I have to apply the more force. For tennis ball, I have to apply the less force because the mass is less. So the force is directly proportional to mass. If more mass means we need more force. If less mass means we need less force. Here the tennis ball has less mass, so less force needed because force is directly proportional to m. Mass less means force also less. Here the cricket ball has more mass and more force. So force is directly proportional to m. The mass is more means the force also more. In second one, here I took two cricket ball. So mass is same mass. But I throw with a different speed. This is 5 meter per second. This is 10 meter per second. So I throw with these two with different velocities. One is a 5 meter per second and another one is a 10 meter per second. Sorry. This is throw with 10 meter per second and this is a throw with 5 meter per second. So throw with a different speed. So throw with the higher speed, more force is required. If I stop to this cricket ball, I have to apply the more force. I need to apply the more force. For here, I have to give only the less force. Less force is need to stop this 5 meter per second cricket ball. So the force is directly proportional to velocity. If velocity is more means the force also more. If velocity is less means the force also less. 5 meter per second, 10 meter per second. So here I need to apply the less force because the velocity is less. Here I have to apply the more force because the velocity is more. So from the previous concept, the force is directly proportional to m. For here, the force is directly proportional to velocity. So from this, we can understand the term momentum. The quantity of motion in a body depends on the mass and velocity of the body. So the motion of a body depends on the two factors. One is a mass and another one is a velocity. This gives another term as known as momentum. That means the momentum of a body is defined as the product of mass into velocity. Momentum equal to mass into velocity. The mass is represented by the small letter m. The velocity is represented by the small letter v. The momentum is capital letter V. So when we multiple mass into velocity, it gives the momentum. Here P is momentum, m is the mass and v is the velocity. So how to measure this momentum? P equal to m into v. The m is mass, it is measured by kilogram. The velocity is meter per second. So the unit of momentum is kilogram meter per second. Every moving body possesses momentum because if you take a moving body, it has mass and velocity. If you multiple mass and velocity, it gives the momentum. So every moving body possesses momentum. Since momentum depends on the mass and velocity of your body, so your body will have a large momentum. P equal to m into v. That means B directly proportional to m into v. If more mass means the momentum also more. If more velocity means the momentum also more. Both mass and velocity is large means the momentum also large. Because B directly proportional to m into v. This is given. If it mass is large means the momentum also large because P equal to m. If a velocity is large means the momentum also large. If both the mass and velocity is large means the momentum also large. The next one, Newton's second law of motion. The second law of motion states that the rate of change of momentum of an object is proportional to the applied force in the direction of the force. The momentum means it contains the mass and velocity. If you apply a force on this object, it can change their state of momentum. That means it can change their speed. When the speed is changed, the momentum also changed. So that is directly proportional to the force. That means the rate of change of momentum, the rate represents time, the rate of change of momentum is directly proportional to the applied force in the direction of the force. This is the object. If you apply a force in this direction, the object also move in the same direction along the applied direction. If you applied the force in opposite direction, the object also move in opposite direction. The object always move in the direction of the force. Here the direction of the force is this. So the object move in this direction. Here the direction of force is in this direction. So the object also move the same. So how to calculate the mathematical formulation of Newton's second law of motion? Here we say that F equal to ma. How we can derive the F equal to ma? When two bodies, heavy one and light one, are acted upon the same force for the same time, a light body attains higher velocity than the heavy one. Example, wait. Here I took the two objects. Okay. It has mass 5 kilogram. It has mass 1 kilogram. I apply the same force, 5 Newton, 5 Newton. And a light body attains higher velocity. So it moves higher speed than the heavy one. But the momentum gained by both the bodies is same. So the link between the force, when I apply the force, is starting to the moving. So the momentum of the both object is same. So the link between the force and momentum is expressed in the Newton's second law of motion. According to the Newton's second law of motion, the rate of change of momentum is directly proportional to the force. So we can write force equal to change in momentum by time. The rate always represents time. Consider a body of mass m. So you consider this is a body of mass m having initial velocity u. So the momentum is mu because the momentum is mass into velocity. Initially it has u velocity. Suppose a force is applied on this body for a time t. The velocity will be changed from u to v. Now the momentum is mv. So how to calculate a change in momentum? The final momentum minus initial momentum. The final momentum is mv and the initial momentum is mu. So mv minus mu. So the F equal to change in momentum by time. The change in momentum is mv minus mu by t. Here I took the m as a common, so v minus u by t. V minus u, you know that is acceleration, change in velocity. The rate of change of velocity is given as a acceleration. So F directly proportional to m into a. So for removing this proportionality, I added the new constant, that is a k. So we can write F equal to ma. That means force equal to mass into acceleration. This is a Newton's second law of motion. From this we can rearrange A equal to F by M. If M transported to left side means F by M equal to A. From this we can say that the acceleration is directly proportional to the force and inversely proportional to the mass of the body. So A is directly proportional to the force and inversely proportional to the mass. The acceleration produced is inversely proportional to the mass of a body. Therefore, if the mass of the body is doubled, if a mass is doubled means A direct inversely proportional to 1 by M. If a mass is doubled means acceleration of the body is half. See, if a mass is doubled, the acceleration is 1 by 2. And if the mass is half, maybe mass is half. That means A equal to 1 by 1 by 2. So we can write A equal to 2 when it come up. So the acceleration is doubled. The acceleration is inversely proportional to the mass of the body. It means that it will be easier to move light bodies than the heavy bodies, because the heavy bodies have the mass is more. So we need to give the more force. What is the unit of Newton's second law of motion? F equal to ma. M equal to kilogram, A equal to meter per second squared. So kilogram meter second power minus 2. So the unit of force is kilogram meter second power minus 2, or we can simply say that Newton, N. The application of Newton's second law of motion is that a cricket player moves his hand backward on catching fast cricket ball. Why? If F directly proportional to M into V minus U by T. So when we are increasing the time to move the hand at the backward, so the time is increased. When the time is increased, the force is reduced. So force get 0. So the cricket player, the catcher will not hurt when he extended the, when he moves his hand backwards on catching the fast cricket ball. So when we move, a cricket player moves his hand at backward, the time is increasing. When the time is increasing, the force gets 0. So due to that 0 force, the cricket player doesn't get hurt. The next one, Newton's third law of motion. To every action, there is an equal and opposite reaction. This is a statement of Newton's third law of motion. See here. Here, a boy exerts a force on the ball. So, in this direction. The ball also exerts an equal force on the boy in the opposite direction. How we know that? A ball apply a force on the boy. See here the boy is wearing the skating role. So due to the opposite force of the ball, the boy move at the backward. So it shows that a wall exert equal and opposite force on the boy. So this is applied force, the boy apply a force on the wall. This force is the wall applied force on the boy. So there are the two forces but in equal magnitude but opposite direction. This is called Newton's third law of motion. Some examples for Newton's third law of motion. When we walk on the ground, then our foot pushes the ground at the backward. And in return, the ground pushes our foot forward. So there are the two equal and opposite forces. Due to that two equal and opposite forces, we can walk forward. And when a man jumps out of a boat to the river, the boat moves backward away from him because he is applying the force in this direction. This is an action force and this is a reaction force. The next topic is conservation of momentum. In the second law of motion, we have studied that every moving body possesses the momentum. That means if you take a body, it has a mass and it is moving, means it has a velocity. So when we multiply mass into velocity, it gives the momentum. So every moving body possesses momentum, which is equal to the product of the mass into velocity. So momentum we can write mass into velocity. So now we have to understand what is the term conservation of momentum. We know the momentum is mass into velocity. What is meant by the conservation of momentum? Suppose a speeding truck, here one is a truck, this is a truck and this is a car. Suppose a speeding truck hits a stationary car, due to which, here they are collide, due to which the car also start to moving. Now in this collision, the velocity of the truck decreased, but velocity of the truck decreased, the velocity of the car is increased. Due to this, the momentum of a truck decreased because velocity is decreased, and the momentum of the car is increased. It has been found that increase in the momentum of a car is equal to the decrease in the momentum of the truck, so that there is no loss of momentum in the collision. This momentum lost by the truck has been gained by the car. This is called law of conservation of momentum. See, in starting it has the mass m1, this is m2. Initial velocity u1 and u2. After collision, it has a velocity v1 and v2. If you take for momentum for this m1 into u1, for here momentum m2 u2, here m1 v1, here m2 v2. So this is a momentum before collision. This is a momentum after the collision. Both the momentums are equal. This is called conservation of momentum. m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So the conservation of momentum is nothing but the momentum will be conserved before and after collision. Thank you for watching. The next class we will see the new lesson, chapter number 10, gravitation.